You're listening to Engineuity, the podcast that dives into the wonderful world of everything industrial. From the birth of the first combustion engine to breakthrough hybrid power technologies, Engineuity examines just about everything the industry has to offer. The podcast provides a platform for industry leaders, engineers, scientists, and small business owners to educate listeners about past, present, and future industries across the planet.
So over the last few years, there's been a really big push in the off-highway industry towards decarbonization. And in recent seminars and webinars, we've been hearing a lot of people's plan to get to a path to zero, and starting to see some real R&D dollars being put toward a whole different range of technologies to get off-highway and heavy-duty equipment into a lower carbon or zero carbon environment. So part of that transition and part of that discussion has been looking at what people are calling well-to-wheel emissions, not just what's coming out of the tailpipe, but where the fuel is coming from, where the electricity is coming from, like where the raw materials are coming from, and that whole cycle of the emissions. And so one of the pieces in this discussion that's come up recently has really been alternate or renewable fuels. And so while electric vehicles and hybrids and fuel cells and hydrogen all have their place in the market, it seems that one of the kind of easy wins for decarbonization is going to be changing to these lower carbon impact fuels. And so in just the last 12 months, and this is probably me not really paying too close of attention for the last couple of years, but like this year specifically in our industry, a lot of the off-highway engine manufacturers have come out and approved HVO as a drop-in replacement fuel for off-highway and heavy-duty engines. And so today I'm joined by Matt Leuck with Neste to talk all about HVO, give us the insight on where it comes from, how it's made, what the features and benefits are, you know, where you can go find it, and some of the comparisons to fossil fuels. So Matt, if you would just give us a quick introduction to yourself, your background, and if you can, just a little hit on Neste and what the company's all about.
Sure. Yeah. And thanks for having me here. So Matt Leuck, I'm the technical manager in North America for Neste. We call our renewable road transportation team, kind of our renewable diesel product line. So I guess I'm kind of the product SME, the subject matter expert for anything technical here in the US or North America. I work with our commercial team, public affairs team, marketing, everything, kind of making sure everyone knows what the product's all about, what we do. Background-wise, mechanical engineering. I started my career at Cummins, so I come from the diesel engine world with equipment. My focus there was upstream oil and gas, so I spent a lot of time in my early career on drill sites and frac sites and all this other stuff. Just being around engines and test cells and dyno rooms and things. Now I'm kind of the fuel expert for Neste, who we are the largest renewable fuels producer in the world. We make renewable diesel, we make renewable jet fuel. It's called SAF sometimes, sustainable aviation fuel. We do renewable polymers and chemicals. The company's been around since the mid 1940s, based in Finland after World War II. But now we're transitioning out of the oil market into the renewables and trying to maintain our spot as the top renewable fuel producer in the world.
Yeah, Neste was fairly new to me, but going through and doing some of the research on the company, it's not your traditional oil company, right? Not your. There's a really heavy focus on renewables, which is kind of refreshing to see. Jumping into HVO, so I suppose we should define the acronym HVO. I've seen written as either hydro-treated or hydro-cracked vegetable oil. So can you give us a basic understanding of what that means? I think vegetable oil is probably pretty common. Everyone knows what vegetable oil is, but what is the hydro treating or hydro cracking process?
Yeah, so HVO is kind of the term that's used more in Europe. It's not as common in the US. Here we just call it renewable diesel. They all mean the same thing. Mm-hmm. Basically, you get into these oils and kind of quote fats, oils, and greases. They contain fat molecules or triglycerides. It's three hydrocarbon chains bonded together into a fat molecule. But if you can break that molecule apart and separate those three hydrocarbon chains by themselves where they're not bonded, you can make a liquid fuel out of it. So that's kind of what hydro treating is. We use hydrogen and some catalyst material at high temp, high pressure. It's kind of a refining type operation, right? It's, if you were in a petroleum refinery, you may call it hydro desulfurization. There's all these terms for it. Basically, it's a way for us to take that fat molecule and break it apart and take it from a fat into a liquid fuel. And then we do some other stuff to make it usable at different temperatures. But we're really just taking the energy that's in those fats and turning it into a usable liquid that you can put into an engine that also happens to meet the same spec as the hydrocarbon diesels we're already using. So, there's no limits or blend caps and all that sort of stuff.
Yeah, so that was one of the things that was important to understand, that the fuel meets existing diesel engine specifications or diesel fuel specifications. So it can be blended, right, with any manner of existing on or off highway diesel fuel, or it can be a 100% substitute replacement for diesel fuel, right?
Yeah, and that's one of the coolest things about it, because it's a pure hydrocarbon. You're right. We say fully fungible, right? You can put it at any rate from 0% to 1% to 100%, whatever you want to do, because it's the hydrocarbon. It's just replacing fossil with renewable. Mm-hmm. It's different from biodiesel, where biodiesel is not an actual hydrocarbon. People may have heard the term FAME or fatty acid methyl ester, all these other things. That's a different molecule for a bunch of reasons we can get into if you want to. And that's why biodiesel has, you have a B5 or a B20, and there's these limits of how much you can blend. We don't have that issue because we're a direct replacement for the other stuff.
Yeah, so that's one of the first questions that comes up in a lot of these conversations is, how is it different than biodiesel? So it's chemically it's a different hydrocarbon chain, but what are the other primary differences between HVO and biodiesel? I think a lot of people have had experience with biodiesel and growth or storage issues with biodiesel. We're aware of some of the engine issues we have in the fuel system and things when we're running higher concentrations of biodiesel, which has resulted in engine manufacturers only allowing 5, 10, or maybe 20% blends of biodiesel. So what's different about HVO renewable diesel chemically that separates it from biodiesel?
So I guess on the pure molecular level, the difference is biodiesel contains oxygen. So it's a hydrocarbon with oxygen attached to it. Mm-hmm. That's kind of the base difference in the naming, the blends and everything else. That oxygen, it does some things to the fuel. It can make it less stable over time. So you mentioned storage capability, right? If you had a neat B100 fuel, you may get 6 to 12 months of storage life out of that without having to put in a bunch of additives to stabilize it and things. Renewable diesel, the molecules we make are incredibly stable. So we started making this fuel. Neste developed this technology back in the 90s, and we've started producing it in like 2005 or so, 5, 6, 7 over in Europe. We've got some of that original fuel still in our lab, and we test it every year. It's still good to go. Like all the markers that show fuel degradation and things haven't changed. So we've got, at this point, what's that?
20 plus
17,
years?
Yeah, like a long shelf life. Mm-hmm. It's because the chemistry also doesn't contain oxygens, which means it's very repellent to water. Whenever water and a hydrocarbon touch, that's where you get microbial growth and all the, algae, diesel bug, whatever you want to call it. Mm-hmm. It's a big issue because we don't have that oxygen. Everyone knows that water naturally kind of gets into fuel tanks because they're vented to atmosphere, and it's just, you can't control that, right?
Yep.
Any water that gets into renewable diesel is going to go straight to the bottom and separate super easily. So as long as you have good housekeeping, keep your tank dry, keep your separators clean, all that sort of stuff, you're not going to have an issue. Whereas other fuels may try to grab onto water and create more of an issue with that in your tank. And there's a whole slew of other stuff with it, injector deposits and cleanliness in engines and things like that. And it's just a long list that we're very proud of the product we make. I think anyone making renewable diesel would agree.
Yeah, I mean, it's hard to understate how many problems we see in the field with fuel quality, fuel stability, fuel contamination, right? And looking at modern engines, there's a lot of effort and time spent just trying to get a decent fuel product into the engine, into the cylinder. So that's a pretty big advantage. And I would imagine that like standby emergency generator sets, things like that have large fuel stores that don't necessarily get turned over very often, also would benefit from that kind of stability, right?
Yeah, for sure. We have a lot of inquiries and business with those markets.
Yeah.
We do a lot with municipalities and B2B, fleets and things like that. But when we talk about stability, anyone who runs a generator or like say a piece of ag equipment that parks over the winter, like you can see their eyes perk up. They're like, oh wait, maybe I should look into this more.
Yeah. And anyone that I know that's run diesel has had fuel issues at one point or another.
Yeah, it's the nature of the beast, and hopefully we can solve some of those problems for people.
Yeah, great. I'd like to talk about what the feedstocks are for renewable diesel. So just doing some of my own research, looking around online, there's a pretty wide range of possible feedstocks, but let's start with what you're using today, what Neste is using as a feedstock today first. Where's it coming from?
So right now, our global feedstock pool it's pretty wide. We source from anywhere around the world to get these fats, these triglyceride molecules. But U.S. based, we're mostly used cooking oil, animal fat. That would be like tallow and things, waste from the beef industry. There's some things called like technical corn oil, which is a byproduct of ethanol production. It's kind of a waste from ethanol that we can then take and make diesel out of. Fish oils and fish fats. There's a lot of different things we can use. But I think the market right now is mostly focused on the animal fats and fish oils. Animal fats and used cooking oils. There are producers out there using soy. Earlier you mentioned the life cycle carbon and carbon intensity on all that sort of stuff. So soy doesn't have as good as a carbon intensity score as the others, so we don't use much of it. There's not as much carbon benefit by doing that. So we're mostly focused on the what we call UCO and animal fats right now. So
the feedstocks that Neste is using right now are all essentially waste products. Is that fair to say?
Yeah. It's all stuff that's kind of it's gone through its first useful life, and it's a waste and residue. So we're giving it a second life. We're not sourcing raw virgin type material to do this. We're taking waste from other industries to make fuel. So
do you have any kind of idea of how much of the current waste product you're using for renewable diesel, and how much you can scale while still using waste products?
There's been a lot of studies out there about how many tons of feedstock is available globally each year. I think a year or two ago, like kind of, this is not like today data, but pretty current, there's about 30 million tons of that product annually globally collectible. And the studies have shown by, 2030, 2040, probably get up to like 50 million tons. So there's still a lot of runway for what we're doing right now, right? We're not about to run out of feedstock for what we're doing. But we do have technology that allows us to use different feedstocks beyond that as well that we're developing, beyond the fats, oils, and greases and things.
Can you give me an idea about how many tons of feedstock does it take to get to a 42-gallon barrel of renewable diesel?
Yeah, so I'm pulling up a calculator as I do this. So because we're a European company, I speak in tons.
Metric tons. Okay.
Yeah, if you got 30 million tons of product and you get maybe like an 85% conversion rate from, feedstock weight to fuel weight.
Oh, that's a lot higher than I would have expected.
Yeah, it's a really efficient technology. So maybe 25 million tons of product, and a ton of renewable diesel is 338 gallons.
Get my calculator right here too.
Quick math here. It's about 8.5 billion gallons.
Okay.
And to put that in perspective, right now we make about 1 billion gallons a year. We're expanding some of our facilities in Singapore, Rotterdam. We've got some joint venture projects in California that we're bringing online. In the next couple of years, we'll be at like 1.8 billion gallons ish.
Okay.
Again, run that against the 8 billion gallons capacity of feedstock in the world. Like, we're not going to run out. It's just that there's a lot of capital investment that goes into this and time, and that's kind of the bottleneck right now is getting everyone on the same page to start moving forward like that.
Okay. Yeah. I mean, we've jumped ahead to where the conversation to the capacity piece, but that's trying to put that in perspective of the amount of diesel, fossil diesel fuel that's being used today. Your current capacity is something like 0.5% or something of the current consumption of diesel.
Yeah. When we say we start talking about billions of gallons, it sounds really big, but then you realize how much diesel fuel the world actually uses. It's a giant number.
Yeah. I mean, I was looking, the numbers I have from the US are about 4 million barrels a day, and you've got 42 gallons in a barrel. So, you've got something like 160 million gallons.
Yeah.
Right.
Yeah.
A day.
It's a lot. It's a lot.
Yeah. But to that point, and I think back to some of the introduction, but we don't need to get to a point where every single, gallon of fossil diesel is displaced, right? Because every gallon of renewable diesel that you burn offsets that much carbon compared to fossil diesel, right?
Yeah, I think ideally everyone would love to move away from fossil fuels just because of the carbon footprint, but practically that's probably not going to happen. I mean, I think that's an honest, fair statement, right? And then you look at the other industries like light duty passenger car. If those are going to go battery, that's going to help a lot with the carbon footprint.
Right.
Other industries are moving to different things. So we don't need to transition every single gallon of diesel away, but there are certain core markets that have emissions issues and other stuff that we can start getting in there right now and making a difference.
Yeah. Yeah. And that, I think that also ties back into the application too. The applications that need the stability that can, that need the better water separation and all that stuff. Those are the places to start.
Yeah, for sure.
Getting back to feedstocks for a second, what are the future potential feedstocks? I think when people hear vegetable oil, a lot of people assume that, I did too, that we're gonna take soybeans and we're gonna take existing like vegetable oil, raw vegetable oil feedstocks and crops to turn HVO. So it's interesting to know that it's all coming from waste product. But are there other future feedstocks that Neste is looking at to help supplement?
Yeah, for sure. And you're right. We get that question a lot. Like, how many French fries can we eat? There's only so much used cooking oil. So right now we're in the waste and residue market. So the technology we have that we developed is called Next BTL. It's Neste Bio to Liquid, taking those fats and things and turning them into liquids. Down the road, though, in probably the next decade, there are things like municipal solid waste or lignocellulosics that would be, plant waste, trees, forestry, tree tops, barks, that sort of thing, or corn stalks and husks and all that. Those lignins in there have energy as well. We can convert that into a diesel fuel.
Some people are doing that with ethanol today, right? And they can cellulosic ethanol sources. Yeah. Yep.
There's a goal to be able to scale that to a large production, right?
Yeah.
Even beyond that, there's kind of a next generation of stuff looking at algae. Which is, you kind of call it artificial photosynthesis, right? You just grow the algae, and the oil that the algae makes actually works in the refineries we have now. They make the perfect product. Or even like what we call e-fuels or power to X, where you're taking carbon capture from the atmosphere and renewable electricity to make hydrogen, and you're basically capturing carbon from the atmosphere and making a liquid fuel out of that to run back into a vehicle. These things could be 10, 15, 20 years out, but the technology runway is quite long. There's a lot of money in R&D going out there. So, we're not limited to just what you see right now.
Yeah, interesting. The other inputs into this process. So you've got right now you've got a waste product, right? Your fats, oils, whatever as waste product. You've got it. You're using some energy, heat energy or electricity, right? Heat energy and hydrogen as well. So can you give us an idea of how much input energy is required to make a liter, a gallon, a barrel, whatever of renewable diesel?
I can't really give you an energy perspective.
Or maybe how does that compare to the diesel refining process? Maybe it's a good comparison.
Yeah, so the best thing to look at is the life cycle carbon intensity, that life cycle analysis from the time you collect the feedstock until the fuel, through production, through transport, all the way to the tailpipe of a vehicle, right? Yep. That's the LCA. Fossil diesel, our baseline is California's low carbon fuel standard program. They classify all these fuels in this giant spreadsheet and table. Fossil diesel has a baseline of 100.45, and that's grams of CO2 per megajoule, if you want to get nerdy about it. Renewable diesel for us specifically, it depends on the feedstock because, we aggregate stuff around the world and there's transport and everything else. Our carbon intensities compared to that 100.45 range from the low 20s to the low 40s.
Okay. So that's where you get that 75% reduction claim that we see on some of the advertising? Okay.
Exactly. So, if we take source used cooking oil from somewhere near our refinery, we're going to get like a 24.89, I think is our score. So like a 75% reduction in carbon intensity compared to fossil diesel.
Yeah.
And, the cool thing about this is it is a drop-in solution. So you don't have to install charging stations or hydrogen compression or whatever else you have to do, gas storage. You literally just fill your tank with it and you get that carbon reduction overnight, and it's pretty awesome.
Yeah, that speed to market's, I think, an important piece too. It's something that's there. You don't have to change anything. There's no changes required on the engines. At least the manufacturers we represent in the engines have said there's no changes required, no software, injectors, filters, all that stuff as is. And you can just literally, like I said, fill your tank and go.
Yeah, it's really awesome. I mean, so because it's a hydrocarbon, the OEMs are very supportive. With my background on the OEM side, I kind of do a lot of that work here in the U.S. with those companies as well. Whether it's Cummins, Cat, Detroit, whoever. You're wearing a Kubota jacket right now. I see in the video. And Kubota just last week made an official announcement saying we endorse 100% HVO RD in all of our engines.
Yep.
To an OEM, they realize how clean it is, how pure it is. It's not going to create deposits. It's going to reduce DPF issues. It's going to reduce, oil dilution, all this sort of stuff. To them, I mean, worst case scenario, they're saving warranty claim costs. I mean, and then, best case scenario, they have customers that actually rave about it and push the engine more on the fuel. So it's kind of a win-win for everyone.
Yeah, this is all, like I said, this is all coming up. Kubota just approved it. Some of our other manufacturers have approved it. And so it's bringing up a lot of questions in our industry specifically. One of those questions is, where can we get it? I know you guys have a list of distributors on your website, and it looks like they are all in California. Are you guys currently just focusing on the California market? Do you have or plan to have more nationwide distribution? I'm in Omaha, Nebraska. Is there anybody, that I can go to locally to get supply for renewable diesel?
So that is a tough question. We get a lot, and it gets into supply and demand. So California, right? California Air Resources Board existed before the EPA, so they're allowed to kind of do above and beyond type stuff.
Yep.
And California also has their low carbon fuel standard program, which is a kind of carbon credit based program that incentivizes clean fuels to be in their state as opposed to elsewhere.
Right.
We, Neste, but everyone else in the world cannot even fulfill all of California's demand. So they're kind of a magnet for all the fuel because of that program.
Yeah.
It's hard to justify not taking fuel there. Oregon has a similar program, Oregon's Clean Fuels CFP program. You can get fuel anywhere, but anyone who makes it, there's that opportunity cost of leaving California. You have to quote retire those credits, pull them off the market, so they can add $1 per gallon, $1.50 gallon plus transport. So logistically, right now, it's kind of hard to get it off the West Coast, but we're very open in saying there are a lot of other states out there that are looking at similar legislation, and as soon as those things happen, the fuel is going to be there.
Okay.
I mean, in New Mexico, for example, of all places, they missed getting a program in place this year by like one vote in their legislature. And we see like the Northeast U.S., like New York, will probably kind of pull in a couple other states in a kind of a coalition regional thing.
Yep.
They're very close to getting something done too. So probably next you'll see obviously West Coast, California, Oregon, Washington just passed something. Probably Northeast U.S. next, and then from there, it'll move in from the coast toward the middle. But you're right. There is in Nebraska, you're probably not going to find it at the pump anytime soon.
Well, and obviously, like you said, you can't meet current demand. There's the issue of scale. There's the issue of having to kind of bootstrap a new industry. We see the regulatory structure impacting the technology path a lot.
Yep.
And not just in fuel, but in other technologies and engine after treatment technologies and everything else. So certainly understand that has to grow. I think the fact that it's a drop-in replacement and it's something that can be done today to reduce carbon footprint will have a lot of probably larger organizations wanting to get their hands on it as part of their own ESG targets or carbon reduction targets of operating fleets and things like that. So I suspect there's going to be a pretty substantial demand for a ways to come. What is the trajectory of your production capacity in the U.S.? Are you guys actively adding capacity? Do you have plans to increase capacity, or how fast do you plan to increase capacity?
Yeah, so currently we produce fuel in 3 locations. We've got Singapore, we've got Rotterdam, which is in the Netherlands, and we've got Finland, which is where we're based. Right before COVID hit, like late 2019, we announced the expansion of our Singapore refinery to kind of, there's one refining unit, copy paste, build another next to it, right? Mm-hmm. We're doing the same thing in Rotterdam. We announced that pretty recently, but we do have a joint venture in the U.S. with Marathon Petroleum that we announced. The deal closed in July, August, maybe. Basically, Marathon Petroleum had a facility in Martinez, California that had been kind of offline for a bit, and we each went 50-50 on a deal to take that whole facility, convert it to renewable diesel, and start producing fuel here in the U.S. That'll be online Q1 next year. So in the next few months, we'll actually have domestic production of renewable diesel. So we'll be the first on 3 continents making renewable diesel. And it is.
6 months from agreement to a functional refinery.
It's been surprisingly quick.
Yeah. Wow.
And work had been done a little before that on the business side of the house, but on the technical side, it's been a really quick turnaround to get that done. And we'll have, like I said, domestic production in California Q1 next year, which we're really excited about. And it's a 50-50 thing. Our portion of that's going to be about 1 million tons a year, so 350 million gallons a year of Neste product coming straight out of the Bay Area.
So is I don't necessarily need you to detail your competition here, but are there other people that are refining and making renewable diesel today, or is Neste? Give me an idea of how much of that market you have.
Say like California specifically. All of the renewable diesel in California, I think last I checked, we were like 41% of the whole market.
Yeah. Okay.
There are others out there. So that 59 whatever percent is made up of a few different players. We do have competition. There are some that are pure in the biofuel space. There are some that are the oil majors getting into the biofuel space and doing conversions. We've seen a lot of investment from the big majors. Because I hate to say the writing's on the wall, but everyone kind of sees the trajectory of the market, right? Like the more green you can be, the better things are going to go. So
going back to the comments from the top, I mean, it's at the Diesel Progress Summit this year, you've got oil companies standing up and talking about their path to zero, right? Which is a little off-putting, or not off-putting, but it's a little shocking actually. Just, these guys, they see the future too. They understand where it's going and the part they have to play in it.
Yeah, they do. So there's a lot of investment dollars coming into the space in the U.S. Well, globally, I guess, not just the U.S. I think we definitely want to maintain our spot on the top.
Yeah.
But we understand that there's about to be in the next couple of years, there's going to be a lot of gallons, which is good for everyone, right? Yeah. You get more acceptance in the market. You get more people to understand what it is, less hesitancy to use it. I think it's good for everyone.
So talking about scale, I think the correlator there is the pricing. So understanding in California you're getting $1.50 per gallon. Is that a production credit or a how's that credit work in California?
So there's actually in the U.S. there's 2 kind of policy regimes. One is the state-based programs like California's low carbon fuel standard. That is based on tons of GHG abatement. So like the lower your carbon intensity score compared to diesel, the better your credit value is, right? Okay. There's also a federal program. It's the renewable fuel standard. Yep. That's based on a per gallon basis. And there's a few tranches, but it's basically like per gallon, not a per ton type thing.
Okay.
Our production costs are higher than a fossil diesel. Our feedstocks can be 2 to 4 times more expensive than crude oil, depending on day of the week and what we're buying, right? Mm-hmm. So these credits do help us offset higher production costs. You get in like California, we have a credit market. We'll sell near parity with fossil diesel. Like you're not going to pay an extra $2 or $3, $4 a gallon to get renewable diesel.
Yep.
Because we get those credits that help us on the back end. We could sell it to the market close to fossil, which is really awesome. states without those programs, the price increases because we give up the credit value. But as like I said, as the legislation moves inward from the coast, it should levelize out and be pretty awesome for everyone.
So the subsidies and incentives aside, what's kind of the cost multiple from a fossil diesel, for current production? Give us an idea.
Honestly, that's a good question. I couldn't tell you.
Are we talking 50% higher, 100% higher?
I couldn't even take a guess, honestly, because it really depends on, feedstocks in the world. 20 years ago, you could drive up to McDonald's and go grab their used cooking oil and make your own biodiesel in your garage if you wanted to. Now there's this whole commodity market around all of that stuff. And it really depends on market dynamics. And, we, in our refining, we need more hydrogen than a fossil guy may need. But we don't have to do the other stuff. It all kind of balances out. But as far as a multiple versus fossil, I couldn't venture a guess.
Okay. I think I'm going to try to find some and see how much it costs me to get it to Omaha.
I could help you out with that. I can make it happen. We do have, so, you mentioned our distributors on our website. We have 7 that we currently work with, mostly West Coast based, but some do nationwide. We send a lot of fuel to the OEMs. We send fuel to Cummins and Cat and whoever else to do testing and validation and stuff. We have anyone out there, we do have the ability to get fuel anywhere. But, so, like you said, transport.
So I mean, for if listeners are interested, should they be reaching out to your distributors to regardless of where they're at in the country, I suppose, but are those the right places to direct people if they're looking for a supply of the fuel?
For sure. The website is nestemy.com, and there's a link that says find fuels. You can get our distributor list on there. Our business model, we don't do our own trucking and other stuff. We that's why we have our distributors, our channel partners.
Right.
Any one of those would be the ones to transport it from the terminals on the coast where, we bring it from Singapore, we offload a vessel, we put it in the tanks. From there, it's the distribution model to get it wherever. Okay. So that's nestemy.com. Yep. Is the site? Yep. Okay. Very good. Well, Matt Leuck, thank you very much for joining me today. I think that's all the questions I had. Kind of excited to start getting this fuel in our engines and start hopefully seeing it in the market a little bit more and maybe further east as the regulatory structure allows. We're coming, don't worry. Okay. All right. Thank you very much. I think we'll probably leave it there and people can go check out your website for more information and reach out to your distributors if they're interested. Sounds good. Yeah. Thanks for having me. Okay. Thanks, Matt. Just want to take a note here in the bottom of the show to thank everybody for listening and joining us on the podcast this year. It's been a really fun year, kind of exploring a bunch of different topics. And we're looking forward to next year, planning to continue the pod and looking for ideas, topics people want to hear about, people that you want to hear from. So if you've got any ideas or some thoughts on things you'd like to see on the show, you can go find us at Engineuity, which is ENGINEUITY.ai-engines.com. Or you can send us an email to info@ai-engines.com, and we'd be happy to connect and set something up as we set up our lineup for next year. Thanks again for listening, and have a great end of the year.
Thanks for listening to Engineuity. We record and release a new episode every month. Be sure to follow us at Engineuity Podcast on Instagram for updates about future episodes and industry news.